चलो लाइव आ गए ना आ गए होंगे सर अरे नहीं एक मिनट हाँ हाँ मतलब चला के
Good morning, everyone, and welcome to our presentation today. We're going to be looking at industrial Ethernet and a new solution for testing the cabling and the network that is being used for industrial Ethernet. My name is Wayne Allen, and I'm the field marketing engineer for Fluke Networks in the Asia Pacific region. And I'll be your host for
वीडियो
this
चल रही है
webinar.
ना वीडियो चल रही है ना आवाज के साथ पीछे से आवाज खोलो
There are many levels of testing that you can carry out. The most basic is verification. So we're looking at the very basic functions of evaluating a cable. Have I got continuity? Have I got a gross problem, and whereabouts is that gross problem? What sort of speeds is the switch indicating that's available? And at the far end of testing, we can talk about certification. And this is the normal in ICT environments where we completely certify the cabling to a category or class of category, giving us assurance that we'll know perfectly that the cabling that we're using is up to the job. However, there's a new area. It's the middle ground, if you like, and it's qualification. The qualification takes on a little bit more in the industrial Ethernet environment. Not only are we looking at is the cabling working correctly, but now we're starting to look at will the cabling support the speed that I need? Will it give me some assurance that the cable will meet the client's brief? Will it work? Will it carry my application? If I've got a problem, how far away is that problem? But also when you're looking at qualification, you can do some basic network testing as well to make certain you've got the right connectivity. And so this is an area that we'd like to explore this morning in this presentation. So if we talk speed versus a link category or class of cabling, in the ICT world, there are a number of standards, either from the North American TIA people or the international ISO people, that broadly define what a cable looks like, whether it be a channel permanent link or what we call an MPTL, modular plug terminated link. And within those standards, we're looking to verify a cabling link. And so, for example, a category 5E cabling system, or in the ISO world, a class D link, we measure the frequency out to 100 megahertz. We don't really care what the application is. But if we carry out these measurements, we'll know that our applications will work no matter what they are. However, if we look at IEEE 802.3, which is the Ethernet standard, it broadly defines the performance of connected devices to the network and their connection speeds. 10 base T, 100 base T are examples of IEEE standards. And as I've got listed here, 1000 base T we commonly call gigabit Ethernet. The thing to remember is gigabit Ethernet doesn't require all the bandwidth of what we would call a compliant category 5E link if we were certifying cable. Let me explain a little bit further on this one. If I take my pipe here, which is category 5E or class D link and it's certified, if I apply to that communication pathway the requirements for 1000 base T, which is gigabit Ethernet, you can see I don't need all the requirements to ensure that 1000 base T will work across my cable. We can make use of this to verify that cable is working or not working to carry industrial Ethernet protocols. But I want to be very clear. When we're talking about the speed a cable can support, we are not talking cable category. I must make that delineation.
Hello. Sir,
Just because in this particular example, the tester I've used says the cable will support a 10 gigabit Ethernet connection, it does not mean the cabling is certified to category 6A. That's a whole different ballgame. But what it tells us, what I'm faced with today, installing some cabling or installing some machinery that's going to be operating on my cabling, I can be confident that this cable will support the 2.5 gigabits I've selected. It's also capable of going a little faster, right out to 10 gigabits per second. If we look at some of the common cabling configurations we use out there, the far end is typically terminated by, in most cases, RJ45 style terminations. But if we're talking industrial Ethernet, sometimes more rugged connectors are used. Along the lines of the M12 decode, Xcode, sometimes you'll even see an M8 connector used in the industrial Ethernet environment. The common denominator here, though, is twisted pair cabling. And if we were to look at how something is installed, we can break it down to a couple of link models. So it really doesn't matter whether I've got cameras, wireless access points hanging off the cabling, whether I've got my telephone system, a laptop PC, a workstation, or even an industrial switch, variable frequency drive, or some automation equipment. They all rely on the cable working correctly. Some of those common issues you see with cabling include bad wire mapping, split pairs, crossed or reverse pairs. That's an installation failure. Shorted pairs, something's happened on the production line. Someone's put a nail in the cable, someone's put a staple through the cable. Open pairs are not uncommon. You know, these cables are made from copper. Copper is brittle. And over a period of time with use, especially if the cable's moving a lot, a copper wire can break. You get bad or damaged cable. And over time, you can get high resistance terminations. And that could give you some problems if you're relying on power over Ethernet to drive an IIoT sensor, or you're taking video as part of your process network. You don't want high resistance terminations. So the first step is always, whether you're troubleshooting cable or you're looking at a new installation, has it been wired correctly? Do the wires go to the right pins? Do the wires go all the way through? If there's a problem, where is the problem? How far away is it from me? And importantly, is the cable up to the job I want it to do? So as you can see in my diagram here, I've got my cable terminated at the far end. And to accommodate industrial cabling, not only is it terminated in RJ45, but typically the right equipment can terminate a cable in M8 or M12 as applicable to the job they're doing. And you use interface cables to get rolling. So in this particular example, I can see that I've got a cable that's got a short circuit, and the cable length is 4.5 meters. So that's very clear here. I've got a problem at 4.5 meters. So we've part of the way down to isolating the problem. If we take this a little bit further, I can see that my other pairs are out around 26.5, 27 meters. And that's normal with twisted pair Ethernet. Twisted pair cables, depending on the twist rate, have different lengths for each pair. But very clearly here, I can see at 4.5 meters down the cabling, I have a problem. So if you refer back to the diagram, more than likely, somewhere along the lines of the cable, someone's put a nail, a screw, or possibly a staple to the cable, shorting one pair out. Some of the other common problems that you can see with cabling include things like this, a reversed pairing. We have two wiring codes that we can use, a T568A or a T568B. And if two separate technicians terminating different ends of a cable are working to different wiring standards, this can be a very common issue. Split pairing is a common issue. With data cabling, we don't wire 1 to 1. When we get down to the higher pairs, pairs 2 and pairs 3, we actually wire 3 to 3, 6 to 6, 4 to 4, 5 to 5. But inexperienced technicians just go 3 to 3, 4 to 4, 5 to 5, 6 to 6. It's a very basic error, but it is very common. So your testing devices need to be able to pick up this sort of issue. A continuity tester, by the way, will not pick up this issue because we still have continuity. Reverse pairing is not common, especially at higher speeds. In this particular case, 10 and 100 megabits Ethernet would work perfectly for us. But if we tried to run our devices at higher speed, we would find a 1000 base T or gigabit Ethernet or higher would not do the job for us, it would not work. What we're looking for when we're looking at cabling is something like this. We need to get a good, clear test result. In this particular case, my cabling was 14.3 meters long. I wanted to test the cabling to 2.5 gigabits per second. So that's a multi-gig speed, and it works perfectly. But the tester has also indicated that I can also support 5 gig and 10 gig speeds on this cable. So I really now know what my system can support. I like to also just notice that you see down the bottom here where it says save as. When I've got a good test result, best practice is to document. So if I go save as, I can record this good result And I can use it later to document my work to prove that when I left the installation, it was good. Or if I was troubleshooting an installation, I left it in repaired state. Now we can take that troubleshooting a little bit further. In this particular scenario, we have a system that might be giving some issues. So you can see here that I have a variable frequency drive connected to my industrial Ethernet system. And I need to verify that this will actually work correctly for me. So as you can see across there on the left, I have plugged my tester, in this case is a Fluke Networks Link IQ, into the switch output port I wish to use, and I hit the auto test button. First thing I see is, here's the switch I am connected to. And I'm in a gigabit Ethernet interface, and I'm in interface 103. So it's port 3 of the switch I'm connected to. And by the way, I have the switch name as well. So I know I'm connected to this particular switch at port 3. And this becomes important if you've got multiple switches in a factory environment. You need to precisely identify where you're connected into. And in today's modern operational technology network, or an OT network as we call it, it's often very important to establish which VLAN you're connected to, because it's not unusual to have multiple VLANs on a particular switch. I can see from the information displayed here that the switch can support from 10 gigabit Ethernet, 10 megabit Ethernet right up to 1 gigabit Ethernet. So I have my speeds. I can also see at the bottom of the screen here that my switch is also offering PoE, because it mightn't be a variable frequency drive that I am going to connect. It might be some sort of inspection camera or some other IoT device that relies on getting the power from the network rather than the local mains power. So let's explore that a little bit further as well. So in this case, once I finished testing, I can see that switch was offering me power over Ethernet. I can see the switches of a modern design. So it's offering me power over Ethernet on all 4 pairs. Being of a switch of modern design, it's actually complying to the IEEE 802.3 BT power over Ethernet standard. But for backward compatibility to older devices, I can see my switches offering me up to 25.5 watts of power, which is what we call a class 4 supply. If I was using more modern, higher power requiring devices on my network, I can see that this switch port is capable of going further. So it can also support up to 30 watts of power supply, which is a class 5 802.3 BT power supply. Very important as we, in the industrial automation environment, move further to using industrial Ethernet, and we're powering devices under Industrie 4.0 from our network switches or inline power injectors, that we can clearly establish that the supply device has enough energy to run the networked device correctly. And these are some of the measurements you can make to prove that out. Once you've established the switch port is working correctly, you can take that a little bit further. And as you can see in this graphic, I've reconnected at my switch, and I've moved my tester out to the field. I'm actually in the cabinet housing the variable frequency drive. And so I've been able to connect in. I can repeat all those measurements to see that I'm getting all the correct information from my network switch. If I wasn't getting all the correct information, it's just a matter, as you saw in the earlier slides, of terminating the cable and running the cable tests to find out what is actually wrong with the cable that I'm running out to my variable frequency drive in this particular example. And I'm sure you can think of many examples in a production environment where this sort of troubleshooting is very beneficial. And of course, no job is done until the paperwork is done. As I mentioned earlier, all this testing gives you some results that you can save on board. And in my particular example, I was using Fluke Networks Link IQ Cable Plus Network Tester to verify my cabling and my network connectivity. From a cabling point of view, I was successful in my testing. I recorded that successful result on the tester, uploaded it to my laptop PC, and using Linkware software, I was able to generate a test report for my customer. So they can clearly see that I had configured the cabling correctly, and this cabling will support up to 10 G-based, 10 gigabit Ethernet. When things go wrong, and it doesn't work, you can still save the result, but I can clearly see that this particular link can't go beyond 100 megabits per second. At any higher speed, the link is not going to work. So even though it failed, it's okay for low-speed devices, but it will definitely not support high-speed devices. So it gives you a clear indication of what you're dealing with. And if you are verifying your connection to your automation network, here's my connection. I can clearly see the switch port I'm connected to. I can see the name of the switch, the VLAN that I'm connected to, what we call the speeds and the feeds. So I can see what speeds are supported with the connection. And because I was using power over Ethernet, I can see that this particular connection supported 2-pair power over Ethernet. So this is an 802.318 power supply. But fully load tested, I was able to deliver my 25.5 watts, and I was able to get 30 watts as well. So I know that I have the capability to drive the device I'm putting on the end of the cabling. Here is my proof, whether it's to my boss or to my customer, that my workmanship was good and I'm handing over a good working system. So to finish up this presentation today, the cabling you are using in your industrial plant is the foundation for your control network. And as with anything that's worth building, you build a robust foundation using good quality components. You will not have a good copper network if you don't use good quality components. I have seen good quality components ruined with bad workmanship or operating networks with bad workmanship. So make certain you validate, qualify, or certify the cable correctly once it's installed. Basic pair mapping or wire mapping, as it's called, is not good enough. Won't pick up split pairs, and it will hide issues in the cabling that may give you problems as you try to commission systems. Survey work has shown that over 50% of all industrial networking issues are related to cabling. It makes perfect sense to remove the cabling from the troubleshooting equation when you're commissioning the plant. one thing that people need to consider is how much does an outage cost your company at lost production? Especially if it's related to the cabling. And we know that 50% of all faults are cable related. Really, it makes good financial sense to be testing everything correctly as you go. And if you're unsure, because industrial Ethernet is a new area, we've been used to field bus technologies before, as we're moving to Ethernet. If you're unsure, seek advice. Many of the suppliers of equipment have great guides for their products. They have documents on how to install and test things correctly. Fluke Networks, we're considered as one of the world leaders in cable testing. We can certainly help you. We have documentation we make available. So that brings me to the end of this morning's session. If you have any questions, we would like to hear from you. And you can email us at apacmarketing@flukenetworks.com. So that's apacmarketing@flukenetworks.com. And we'll be happy to take your questions. With that, I would like to thank you for your attention today. I hope you found this presentation informative. And from here, I'd like to wish you a good day. Enjoy the rest of the conference.